Dear students, in this video we are going to learn about discrete mathematical structure. In that, firstly we are going to see basic connectives and truth tables in module number 1. Before that, I will give you a short introduction about discrete. What is discrete? So it is countable, distinct and separable values. For example, if you are counting number of students in the class and number of apple in a basket, these are all discrete values, okay? So what about continuous? When we compare with continuous, we can easily understand this discrete. Okay. So what is continuous? If we are having between the interval 1 and 2, if we are having the values 1.005, 1.45, 1.53. So these are all continuous types. Okay. We should not get decimal numbers in discrete. So it should be countable, distinct and separable values. So let's learn about basic connectives. Before getting to basic connectives, we should know what is the statement. It should be, so statement should be a declarative sentence, okay? So it should not be exclamatory or command statement. See, if we are having exclamatory statement as what a beautiful evening, get up, these are all command statements, right? We cannot judge anything about these statements. These statements should not be there as a statements, okay? So we cannot judge anything whether it is true statement or a false statements. If we are having a statement what a beautiful evening, it cannot, we cannot say about the statement whether it is a true statement or a false statement. You should not take the statement like this. It should be a declarative sentence. We should make assertions in terms of verbal form, okay? So that is a declarative statement. So simply, if you are having DMS is the required course for CSE, JK Rowling wrote Harry Potter, these are all declarative sentence. A declarative statement can be a mathematical statement like 2 plus 8 it is equal to 10. Whether it can be true or false, it is decided afterwards, okay? So first we have to have a declarative sentence, okay? So here you can represent these statements in lowercase alphabets. It is P you can represent. So another statement, if you are having a, you can represent Q, R, S, T. You can take all alphabets and it should be in the small letters, okay? So next we are going to see about connectives. So with these statements, if we are having P statement as DMS is the required course for CSE. So this is a declarative sentence, right? So with this declarative sentence, we can negate the sentence, okay? So what is the negation of the statement? So first connective is negation. So we are given the statement P. So what is the negation? It is negation P. So what is the connective word you will use? It is not. Symbolic representation is this one, okay? So first one is not. If the statement is true, then what is negation P? It will become false. If the statement is false, then the negation of the statement will become a true statement. This is the first connective. So for another connectives, we have to combine the two or more statement into a single compound statement. Say for example, see this one I have explained now, just now, okay? So here we have P and Q and R. So what are these statements? These statements are declarative statements and we should not use any exclamation or command statement. So for example, command statement is get up and do your exercise. We cannot judge anything about this statement, right? So we must know what is a primitive statement. So what is a primitive statement? It should be a single statement. It cannot be broken down into more than one statement. It should be a single primitive statement. So for example, if Anita studied well, then she can pass in the exam. So Anita studied well is one statement and she can pass in the exam is another statement. Both the statements are in a single statement. So these statement cannot be a primitive statement. So primitive statement should be a single statement, right? So here negation. What is negation? It is we have to negate the given statement. You have to use the word not. So DMS is the required course for CSE. What is the negation of the statement? It is DMS is not the required course for CSE. The truth table is same. If it is 0, it is 1. Okay. And if it is 1, it is 0. So combination of two or more statements forms a compound statement. Okay, so it forms a single statement known as the compound statement. So for compound statements we are having certain logical connectives to get the compound statements. The first connective is conjunction. What is conjunction? It is nothing but you have to use the word and. We have to combine these two statements using the connective word and. So what is the representation? It is p and q. You have to read like this: p and q. You have to use the symbol cap here. Okay, so how you will draw the truth table for the conjunction? If both are true only, you will get the truth value as true, otherwise it is false. See here, we are having the truth table, right? So here P, Q we are having. So how many combinations you will get? 0, 0. Either both may be false statements. One statement can be true. In both the cases P can be true, Q can be true, and both can be true. Okay, so if both are false, then obviously it is false. If one is false, another one is true, then you will get a false statement only. So here also it is false. So if both are true only, you will get a true statement. When P and Q are true, you will get a true statement. This is conjunction. What is disjunction? Either one of them can be true. Okay, then you will get a true value. So what is the connective you will use? It is R. P, R, Q. Symbol is, it is this cup, P, R, Q. You have to read it as P, R, Q. So here what is the word you will use? DMS is the required course was CSC or J.K. Rowling wrote Harry Potter. You have to use the connective word as R. So how you will draw the truth table for disjunction? It is if both are true, false, then it is false. If either one of them is true, then it is true. So one of them is true, then it is true. If both are true, obviously true. At least one should be true. At least one means one or more than one should be true. Then you will get true value. If both are false, you will get a false. You can simply remember, if both P and Q are false, it is a false value. Okay. So next connective is exclusive OR. So what is exclusive OR? It is represented like this. Okay. So P exclusive OR Q. Okay. Exclusive OR connective word is R but not both. Either P or Q but not both. Either P may be true, Q may be true, but not both the statements P and Q may be true. Okay, if P and Q both are true, then you will get a false. Okay, so how you will draw a truth table for exclusive OR? So what are the statements you are having? P, Q, P, exclusive OR Q. So either both may be false, 0, 1, 1, 0, 1, 1 or the 4 combinations. If you are having 2 statements, you will get 4 combinations. If you are having 3 statements, then you will get 8 combinations. What is P exclusive or Q? If both are false, then you will get, it is false. This is a false statement. Okay, and if one is true, another one is false, then it is either or. If any one of them can be true, but not both should be true. Okay, so both, if both are true, you will get a false. If one of them is true, then you will get a truth value is 1. So 0, 1, 1, 0 is the final truth table. Okay, truth values of P exclusive OR is 0, 1, 1, 0. This is for exclusive OR. So next one is implication. If we are having a statement, implication statement, or it is called as conditional statement. It may be called as conditional statement, conditional or implication statement. How you will represent it is P implies Q. So what is the connective word? It is if P then Q. Okay, so if we are having P as DMS is the required course for CSC and Q is the J.K. Rowling wrote Harry Potter, you have to use the connective word if then in between P and Q. If P then Q, you have to write. Okay, so how you will draw truth table for implication? See, P, Q, P implies Q. we have to find implication. So what are the combinations? We have four combinations: 0 0. Either you can write in this way also: 0 0 1 1 0 1 0 1. You can easily remember. Okay, so if both are false, then if both are same truth values, 0 0 1 1, then it is obviously 1. Okay, and 0 implies 1. See here, 0 implies 1 is also 1. A false statement can be a true statement, but 1 0 if you are having, a true cannot be a false statement. In that case it is false. It is false. You have to remember only this: a true statement cannot be a false statement, so it is obviously false. Okay, so this is the final truth values for implication. Okay, so next statement is biconditional. So we are going to see biconditional. What is biconditional statement? Biconditional means you will get both side implications. That is P if and only if Q. So you have to represent like this: P if and only if Q. So what is the connective word? It is if and only if. You can put double F also. You can write if and only if also. Okay. So how you will draw truth table for biconditional statement? It is P, Q you will be having, and you have to find what is P if and only if Q. So what are the four combinations? Both can be 0, 0 1, 1 0, and 1 1 on the four combinations, right? So what is implications? If 0 implies 0, if both are having same value, then it is obviously 1 1. Okay, 0 can implies 1. It is a true statement, but 1 implies 0 will become a false. A true statement cannot be a false statement in implication, I said, right? So it is false statement. So 1 implies 0 is obviously false. You will get a false statement. So what is the final truth values? It is 1 0 0. 1 is the final values for biconditional statement. So these are the connectives we have to use in truth tables. To find the value of truth values, you have to use all these connectives. Okay. Connective logics. See here, if they have given one statement like P or negation R implies Q, then how you will find the truth values for this? So here we are having, yet now we have seen with two statements. So here we are having P, Q and R, three different statements. So how many combinations you have to write? It is P, Q and R. 8 combinations you will get for three statements. So what are the combinations you will get? It is, first you have to write 0 0 0 1 1 1 and 1. Okay, so next one is 0 0 1 1 0 0 1 1. In this way it is easy to write the number of combinations. Okay, 8 combinations. 0, next is 0. Okay, here it is 0. Okay, 1 0 1 0 1 0 1. So 8 combinations. So next we have to find what else they have asked. It is negation R, and then we have to find negation R implies Q. We have to always solve the bracket first. Here we are having negation R. Negation R is not, we have written. We have written all the 8 combinations of 3 statements, and we have to write, we have to find negation R, and we have to find the bracket. Negation R implies Q, and afterwards you have to find P cup negation R implies Q. Okay, so here how you will negate the statement? It is, if it is 0, then it is 1. If it is 1, it is 0. If it is 0, it is 1. If it is 1, it is 0. If it is 0, it is 1. So 1 will become 0. Here it is 1 0. So next, negation R implies Q. From here to here you have to see. You have to see to the order. From negation R to Q you have to see. You should not change the order. Okay. From negation R to Q you have to see. 1 implies 0 is 0. A true statement cannot be a false statement. 0 implies 0 is if both are same, then you can write it as 1. 1 and 1, if both are same, it is 1. 0 implies 1, it is 1. A false statement can be a true statement. A true cannot be false. Okay. So 1 implies 0, it is 0. 0 and 0, if you are having, it is 1. If you are having same value, it is 1 for implication. Here also we are having same value, so it is 1 for implication. So what is this symbol? It is R. So PR negation R implies Q we have to find now. So negation R implies Q is here, P is here. So P R this value 0 R 0 is 0 only. 0 or 1 is 1. Or means at least 1 should be true. Then you can write the value as true. 0 1 is also 1. Okay. Here also 0 1 is 1. Next value is 1 0 is 1. Okay. So here remaining two values we are having is three values. 1 and 1 is 1. 1 0 is also 1. Here also 1 and 1 is 1. Here also 1 and 1 is 1. So if at least one of them is true, then you can write it as true. So here all these values are, we are having 1 1 1. Here we are having all the values as 1. Here only in the first one we are having 0 0 0. If both are 0, it is 0. So how many 0 you will get? Only 1 0 followed by 7 ones. Okay. So this is the value, final value you have to find for PR negation R implies Q. Okay. So next, what is tautology? It is nothing but if you are having a compound statement and the truth value of the compound. What is compound statement? Just now we have found it. It is P R negation R implies Q is called as compound statement. This is a compound statement. How it will become a compound statement? We have connected two or more simple statements into a single statement, that is compound statement. Okay. So how, when a compound statement have a truth values as true for all the truth values, okay, so for all the combinations if we are having true, okay, then it is called as tautology. What is tautology definition? A compound statement is called as a tautology if it is true for all the truth values. Okay. A compound statement is called as tautology if it is true for all the truth values. Okay, if you are having the truth value is true for all the values, okay, then you can call the statement, compound statement, as a tautology. You have to denote it as T naught. It is represented as T naught for tautology. If the compound statement is called as contradiction, okay, it is called as contradiction if you are having all the truth values as false. The same statement you have to replace, instead of true we have to replace it as false. See here, if we are having all the truth values as true, then it is called as tautology. If it is contradiction, then all the truth values are false. It is represented as F naught. Okay, F naught is representation for contradiction. So example, if we are having P Q and P implies PRQ. So we have to find P implies PRQ. P and Q statements are given as two statements, declarative statements. Okay, or prepositions also you can say for the declarative statements. Another name is prepositions. Okay, so P Q, what are the combinations? 0 0 1 0 1 1 0 and 1 1. Okay, so first what we have to find, first we have to solve the bracket. Okay, so what is here in the bracket? PRQ. So what is PRQ? It is 0 or 0 is 0, 0 or 1 is 1. At least one value must be true. 1 0 is also 1. 1 1 is 1. So next we have to find P implies PR Q. So what is the implication of these two statements? See here, we have to see from here P to P cup Q. So 0 implies 0 is, if both are same, then it is 1 in implication. If both are same, it is 1. If both are same, it is 1. Here we are having 0 implies 1. It is obviously 1. A false can be a true statement. So it is 1. 0, 1, 1 is 1. Only in the case 1, 0 is 0. 1 implies 0 is 0. Otherwise it is true only for implication. So what we got, it is 1, 1, 1, 1, 1. So all the truth values are true. So what you will declare, it is a tautology. So compound statement is a tautology. It is represented by T naught. All the truth values are 1, then it is tautology. So you can try this statement. The statement is P and negation P and Q. So what you will get is, it is contradiction. All the truth values will be false, false, false. Okay, so you have to remember what are the basic connectives in the first module, in the first section, basic connectives and truth tables. You have to remember what is declarative statement. You should not use command or exclamatory, and it should be a declarative sentence. Okay, and the remaining is connectives. We have seen negation, conjunction, disjunction, exclusive or implication, by conditional statement, and what is tautology, contradiction. And if the 3 statements are given, then how you will write the combination? 8 combinations will be there. You know how to draw the truth table. They will ask for prove that the truth table for this compound statement is a tautology or contradiction, or show that whether it is a tautology or not. So you should practice for the truth table. Thank you.